for the purpose of your references so you can get it. And hopefully this is close to me so you can be able to get it. Okay, so here you come to your, let's say this is you type your CPU data, and you come to the CPU data which you have here, and this is the first interface which you get. In this CPU data which we have here, there are different types of CPU architecture. We have NIOS to RIM. So I'm going to use RIM. Okay, I'm going to use RIM Day1 SOS. Right? This is the CPU which I'm choosing to use. Remember, RIM, it's one of the assembly, one of the CPU which help us to perform the assembly. Help us to perform the assembly program which you're going to write here. I hope you can see this interface which you have here. In this interface, we have the following. It starts from the global start. Means this is a starting of our RIM version 7, which marks that it's going to be global. Whatever things you're going to write there, they can be visible, they can be accessed in any part. Okay? Next, we have one more which is called _start colon. What is this? You in the class, I mentioned this one. What is this? Rebel. Excellent. So this is a rebel. Rebel means starting. We are going to start from here, right? On my left side here, do you see here, what is this? Registers. Remember the registers, right? So these are the registers. So we have a different registers here. I may reduce here. I may reduce the size. You can see. These are the registers. You see the heading here? These are what? Registers. Starting from register 0 here till register SPSL. But from 0 to 12, I may call this as a general register, or I may call this as from 0 to 6. These are mostly used as a general purpose registers. 7, special register. Okay, special register which stores temporary input from other memories, from other values. Okay, so we have register 0. Now, if you don't follow, if you don't understand, please raise your hand. Okay, so every register you can count how many zeros are there. 1, 2, 3, 4, 5, 6, 7, 8. 8. These registers you can see, look here. The format is what? Look down here. Hexadecimal means what? 16, right? Here, every 0 carries 4 bits. Every 0 carries 4 bits. Now, how many zeros are here? 8. Now, how many bits do we have? 32, right? Means this 32, right? So half of it, you have seen some registers which are half, right? There are some registers which are divided into 2, like having 8 and another 8. So here in RIM version 7 means 32. These are 32 bits, which means we have processor 32. Processor 32. Okay, processor 32 bits. So we have R0, 1, R2, register 1, register 0, register 1, register 2, register 3, register 4. So these are the registers. Okay, registers. And the size of register, this is size of register is word. Word means 32 bits here. You get it? The size of register is how much? Word. And the word is equal to 32 bits. In a previous class, we saw that a word is made by 2 bytes, right? Which is 16. But here in RAM, a word is considered to be 32 bits. Okay? 32 bits. Now, the size you can change. Let's say I want to change to byte. Okay? Even format can be changed. I'll make it big here. Let me say, okay. Okay. I can even put half words here. We can see them. We can change the setting here. Let's say, okay, fine. So here, we were having 32 bits. Let's remain by the default which we have here, right? 4. Was it 4? 8. 4. 4. So these are the main part which you understand. Registers. And why do we need the register? Why registers are needed? To store data, right? Data can be stored in one of these registers, right? And data can be, we can store the data in one of the registers. And also, these registers, some of them, they can point to the next instruction. For example, PC. PC means what? PC is program counter register. I'll repeat again. Program counter register. What does it do? It points to the next instruction. What is instruction? Set of codes, yes. So it's going to point to the next instruction. That is PC, right? So here we have them as like this way, right? So we can have, this is link register. This is called the link register as well. We shall see how they work. I repeat once again. This is from the right side. Here, from the left side, we have the register, and you can see the way they are placed here. Another one, this is called ST, is a stack pointer register, right? I think it's a stack pointer register. This stack perform first in, last out, or last in, first out. Last in, first out. Leave is a leave for right, leave for. If you come last, you'll be the last. If you come last, you'll be the first to be out. Means what? It has only one open door. Okay, you go there, you stuck. You have the word I'm stuck, right? What does it mean to be stuck? For example, you're doing code, I'm stuck. You cannot move, right? You cannot move, right? So there are two things. There's one, last in, first out. Another one, first in, first out, which is FIFO. FIFO is a queue. Queue is what? First in, first out. Or come, serve. First come, first serve. Like the queue which you made there, right? In the cafeteria. The queue which you made there is what? Queue. First come, first serve, right? Nobody should jump. If you're in the middle, you cannot go and serve. The first come, first serve. Right? Now, if they change, they say now, we are starting from the last. Last is going to be the first. So here, we have the linker, which can help us to, this linker help us to connect to the next register as well. Now, coming here to the important part here. We are going to write the first code here, the first program, in the short time we have, and I want to implement the same. So, I mentioned global start indicates that the code which I'm going to write here, they're going to be global or they can be accessed here. Start is a variable which indicates the beginning of our code. Now, we are going to do mnemonic. For example, I'm going to move, I put space, I'm going to move, look here the memories which we have here. We have R0, right? I start from the register 0. I start from register 0, register 0. I want to move, let's say I want to move today. Which date are we today? What is today's date? 19. I want to move 19 into register 1. Means what? Transfer 19 into what? Register 1. Okay? R0, right? This is register 1. One more point. These are not case sensitive. You can even write in a small letter. Okay? You can even write them in what? Small letter. Now I move 19 into what? Into register 1. Second, move in R1. I'm going to move a month, right? 09. Okay. Again, move in R2. What I'm going to move? Which year? 2023. Okay. This is the move. Mnemonic. Okay. This is mnemonic. To end our code, you write this one. SWI. SWI. SWI stands for what? Stands for software instruction. Okay, it's a software instruction. You can call like a software instruction or software instruction interpreter, interrupter. You know to interrupt, or you may call software or system interrupter. You may find a different version. They may say different version. You know to interrupt means to make, to disturb somebody. Don't interrupt me. You understand? Maybe I wrote interrupted is supposed to be RA, right? Interrupted. Interrupt. I think this is correct. So this, it indicates that the program ends here. Okay? So we do SW0. Okay, SW0. All right? Now, this is 1. You press F5 or compile and run. Okay, it fails because here I made this mistake here. I remove this one. Here it shows here. Down here you see. It shows if it is successful. So if I remove and I press here, system SW, which one is failing? R1? Which one? R1, move R1. Oh, what is that? 19? What is missing? Is it 0? Remove this one. Global moral. Let me remove this one. Okay, so it did not take much of those inputs, all of them at the same time, right? So here compile succeeded. Let me again reload. When it is reloaded, it comes here in disassemble. I come back here to editor and I compile. Okay, compile, succeed. Okay, compile, succeed. Means what? Means that I moved this 19 into R0, right? I moved 19 into R0. Let me add one more. I move I'm going to move in R1 9. I'm going to move in R2 20. Let me just go with the small numbers and see. Okay, succeed as well. I'm not sure why that was throwing an error. Probably it was recognizing the space here. Let's again put here, but space does not cause an error. Succeeded. Yeah. Input 2023, and I put 08. Fail. Okay, correct. What does it mean, this one? It means that this number, they are bigger than what it can hold. Let me put here. All right, correct. 2023 is above the integers which is registered. That's why it was throwing an error. 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I come back here. I'm going to put only 23. And I'm going to put here. Okay, fail. Okay, this cannot write it. Okay, I'm going to put here. Date is 19. Month is September. And the year is 2023. I compile. So it's compiled. Important point here to see for all of you before the bell rings. So look here. Once you finish to compile, watch here for a while. Watch here for a while, please. Jonathan, look here for a while. Once you write here, you write this one, and you compile. After compiling this, okay, after compiling this, you come to step into, okay? When you click step into F2, it shows you what you have moved. In R0, you see here, R0, what do we have here? 13, right? 13 means 0013. Why? This is hexadecimal, right? So we can change to, you can change this to what? We can change this to, base 10. Listen here, listen here. Base 10 is known as decimal unsigned. So you change here, it changed here. Okay? Decimal what? Unsigned. Then it shows you the true value. So what did we put in R0? R0 we put date, 19, right? And what about R1? 9. Step 2, again F2. We put 9. You see them? Now, what about R2? What did we put in R2? 23. Again step 23. Okay? Then the program ends. Right? Then the program did what? Ends. So this one, it shows us that we have successfully written our what? Our command. Okay? So we step into step F2, step over, and again you can step out, means you can finish or you can continue to keep moving, or you can even stop or restart all your coding. Okay? So this is the first thing which we did. What is that? This is move. For the sake of your point, I want all of you right here today, please, to submit this. Okay? It's in your browser, right? Yes, sir. Screenshot of this one, right? You prepare because you're going to eat. You're going to eat. I'll give you deadline till 2 o'clock. Okay? Till 2 o'clock. Yes, please. I'm coming. Screenshot. Yes. You did a mistake. I saw the mistake. Oh, you did a mistake. You did not go now. Only one is correct. The rest two, he did a mistake. He didn't see from the beginning. No. Yes. Yes. You cannot see? So to help them. Oh, they made a mistake. You didn't check from the beginning. Oh.